Hey guys, this is Shreyans and welcome to Daily DSA Practice. And in the top interview questions, our next question name is find duplicate number, right? So let's go through the question once. Given an array of integer nums array containing n plus 1 integers, where each integer is in the range 1 to n, okay? There is only one repeated number in the nums array, return that repeated number. Okay, so let's understand this question with an example. Okay, so let's take an example 1 3 4 2 4. So given an array of nums array, so this is our nums array containing n plus 1 integer. So the length is 1 2 3 4 5, right? So length is 5, right? So it is 4 plus 1. So n is 4. So integers where each integer is in the range 1 to n, right? So the integer value would be from 1 to n, which is 4, right? And why the array length is n plus 1? Because there is one duplicate number, right? So here in this case 4 is a repetitive number, right? So we have to return that number which is a duplicate one. So you understood the question? So we have to find the repetitive number in the array, and the array can be unsorted also, right? So that is the question. So you already know the drill, right? What is the drill? First is find use case. Second is brute force approach with complexity, time and space complexity. Third is what? Efficient approach with time and space complexity. Fourth, we should have to write clean code. And very important is we have to think out loud throughout the process. Okay, so let's first start with find use case. If you miss this step, find use case, so what mostly the candidate or even let's say who don't give much time to this step, what mistake they will do is, what mistake can happen if find use case is not done. So now let's say what if the nums array interviewer given 1 2 3 4 4, okay, 1 2 3 4 comma 4, and so what we will assume is, by reading the question is, so we will assume that okay, integer is in the range 1 to n. So length is 5, 1 2 3 4 4. So length is 5. So the integer, the number of integers which would be in the range 1 to n. So it would be 1 to 4, right? So what we will do? We will do sum of nums array minus sum till 1 to n. So it would be 1 plus 2 plus 3 plus 4 plus 4 minus 1 plus 2 plus 3 plus 4, right? So ultimately output will become 4. So ultimately the first thing which will come into our mind is this approach only, which is nothing but a n into n plus 1 by 2 you will calculate, right, with this one. But this is wrong, right? Because why? We haven't think through much of this find use case. So now let's jump into the find use case. Let's understand is this use case 1 1 1 1 1 1 1 comma 1 comma 1 comma 1. So this is also a valid use case. So here question says that there is only one repeated number, right? So yes, only one number is repeated, but it can be repeated multiple times. So we have to clarify that, right? So now with this use case, can this solution be applied? n plus 1 by 2? No. Now it can't be, right? So now that's why this question becomes little bit tricky. It's not that easy. So now so in the find use case, we have to identify this one. right? A same number can be repeated more than 2 times also. Okay, so let's now take out a brute force. Now let's take out a brute force approach. So let's say it's 1 3 4 comma 2 comma 2. So first brute force is approach is, I'll take out a 1 and I will search at whole. Hey, duplicate is present or not, right? So no. Then I will pick 3 and I will search whole. Hey, duplicate is present. Another 3 is present or not? No. Then I will pick 4. Then I will search. Oh, hey, duplicate is present or not? So what would be the time complexity? Big O of n square. Is space complexity is big O of 1. Can we do little bit more efficient? Yes. So this was approach 1. Now let's say another approach. Let's do sorting. Right? So 1 3 4 2 2 can be sorted. Let's sort it. What it will become? 1 2 comma 2 comma 3 comma 4. Now just iterate and see if any duplicate comes, right? So time complexity is big O of n log n. Okay, can we do little bit more better? Okay, can we take hash set? Okay, let's take hash set 1 3 4 2 comma 2, right? So I have taken a hash set, let's say 1, right? So I have got it. Then 3, okay, got it. 4, got it. 2, got it. Another time 2 comes, hey, I have already got it, it's a duplicate. So what's the time complexity? Big O of n. Space complexity is big O of n. Can we repeat? Can we do something better on the space complexity? Yes. Fourth approach. If you have seen my previous question, then you would know that, okay, whenever the space complexity is not allowed, we always go and look out, hey, can we modify the existing array itself? So can we do that? 1 3 4 2 comma 2, right? And we know that the integers are within a range of 1 to n only, right? So length is 1 2 3 4 5. So integer would be within 1 to 4 only, right? So now let's say 1. So 0 1 2 3 4. So let's say 1. So index would be -1, right? So it will make it negative. 3, right? So make this third index 3 minus 1 0 1 2. So this will make negative. 4, right? So your 4 will become 0 1 2 3. This will be negative. Then it will come 2. So this 2 will be negative. Then again comes 2. Hey, this is already negative, right? Means this is duplicate. Time complexity is big O of n. Space complexity is big O of 1. But now interviewer will say that you cannot modify an existing array. You cannot modify existing array. Now what? Now what we will do? So this is what makes it little bit more tricky. Till now it's all good, and this is actually the expected complexity. But this is a follow-up question. You can what you will do if you cannot modify the existing array. So now if you see it properly, let's 1 3 4 2 2. Just see one thing, what you see here. One property we have to look. So let's say this is index, this is value 0 1 2 3 4 5, let's say. So we have 1 3 4 2 2. Okay, so this one is extra, this is not required. Okay, so now here if you see that, we know the value would be range within 1 to n, right? So here length of array is 5, 1 2 3 4 5, right? So the range so it is nothing but a n plus 1, so the range would be 1 to 4 only, right? So somewhat would be 1, then 2, then 3, then 4, and then 1 would be repeated inside this range itself, right? So now let's say I have a value 1. From 1, where it goes? Value 3. Okay. So from value 3, where it goes? It goes till here, right? So it's a value 2, right? So now value 2, let's go to index 2 now from here, right? So the value is 4, right? So see, 1 2 3 4, so array length is 5, so 4 is done. Now 1 would be repeating. So after 4, right? So now this one, after 4, 1 would be repeating. So repeating can either goes to 1, or it can goes to 3. Either 3 can be repeated, or either 2 can be repeated, or either 4 itself can be repeated. So you got it right. So we have a limited range. So everyone has been repeated once. Now after that, 1 has to repeat. So it can either be 1, either it can be 3, either it can be 2, either it and 4 itself. So now index 4, which one is repeating? 2. And from 2 itself, again this is a loop, right? So for that use case, 2 2 2 2, so index is 0 1 2 3. So let's start with here. So I have a 2, so index 2, again it becomes to 2, right? So this is my, again it goes to 2. So if you see that, now it's a self loop. That's all. So you got it. So now here if you see that, this is the very important thing which we identify, that there is a loop. And if you know that in a linked list there is a similar problem where we identify this point where this duplicate where the two lists interact, at find the point where two linked lists are merged and loop starts, right? So you know, right, tortoise and here algo, I think it's a Floyd algo, right? Floyd loop detection algo. So it has two phase 1. So now let's say here in this case, let's say for example 1 2 3 4 5 6, and then it goes to 3 again. So here we take a tortoise and here we take a hare, right? So tortoise take 1 step at a time, hare takes 2 step at a time, right? So tortoise take 1 step, hare take 2 step. So till when it will do? Till both collide. So this is phase 1. In the phase 2, anyone will start from start, or you can say that will start from beginning, and both take 1 step, step, right? So after that, let's say for example they meet at this point, tortoise and here. So after that, let's say anyone, let's say tortoise, I am taking it here. Now after, they will take 1 step, and ultimately we will find the duplicate. Got it, right? So let's do a coding for this one, right? So this one, So here I have I am taking a tortoise starting from 0. Also my here starting from the first point, right? Now I am starting my phase 1 till when they have to run, while tortoise not equals to here, till they don't collide with each other. So in this, tortoise what will have to do is take one step, nums array of this one, right? So wherever, so let's say tortoise at 2, then it has to go to 3. So here in this example, so let's say tortoise is here. So tortoise is here, so value is 1. So it then goes to this 1th index, then it will goes to 3, right? And similarly, here has to take 2 steps. So nums array of here. So it will take 2 steps. So after that, once it collided, we will start our phase 2. And in the phase 2, what we will do is, we will first keep any one of them. Let's say here we'll keep to the initial point, right? So we will keep to the initial point, and till when the same tortoise is not equals to here, right? So now here if you see that tortoise will take one step, here is going to take only one step, right? So where they were, whatever place they will meet, so we will return, right? So this is time complexity. Again, big O of n, space complexity is big O of 1, and we are also satisfying that we are not modifying the existing array. Okay guys, I hope this question you find it useful, and this property is actually very important. Because of that property only we are able to do this thing. Okay guys, see you tomorrow, and let's continue practice the top interview questions. See you, bye.